Hi there again. I'm going to try to look at the example you sent me where there's a power which is also a fraction. But this would work for whenever there's a power that's bigger than 1 or a power that's not 1. So you had a utility function that was x1 to the 3/2 times by x2. And then we had a constraint that was 100 equals 3x1 plus 4x2, I think. So then, rearranging this, we want to bring both of those to the other side and get 100 minus 3x1 minus 4x2 equals 0. I've just realized you might have had this written the other way around, but it doesn't matter how you do it. You just want to get them all together like that. That's our rearranged constraint. So now we're ready to create the Lagrangian, or however you say it, which is the utility bit plus a multiple of the rearranged constraint. And now we're going to differentiate, but there's something we need to know, which is that if you have, so I'm going to change, I'll just put a box around this, just a bit of information. If ever you have a variable with a power that's not 1, when you differentiate it, the power comes to the front as a multiplier, and then the new power is 1 less than the old power. I'll give you a more detailed example, and I'll introduce some complications. So what if I had 2x5? Then to differentiate that, the 5 has to come to the front and be a multiplier, so it times by the 2 that's already there to make 10. And then the 5 would reduce by 1 to become 4. In this example here, I didn't have anything in front, but here I decided to take it up a level. But the important thing is that the power multiplies at the front, basically, and then reduces. What does that mean for our Lagrangian? Let's have a look. Differentiating with regard to the first variable, the power comes to the front as a multiplier, and then the power has to reduce by 1. You can do that on your calculator if you don't know what it's going to become. But then it's still times by that, by the other variable. And then in the constraint, those two multiply together. So it's not plus, it's minus. But normal differentiation, a variable on its own like this disappears. Okay, let's remove them and move on to the next bit, which is differentiating with regard to x2. And this is much more straightforward. x2 has a power of 1 there, a power of 1 there, so x2 just disappears. And we're left with everything that it is with. And then the final one, you might remember that I said if we're differentiating d lambda, we get the, that bracket should be there, we get the whole of the constraint that's been rearranged. So that's equation 1, that's equation 2, that's equation 3. We now need to set them equal to 0 and solve them simultaneously, which I'll do in the next video.